Alright, so we're going to go ahead and work on this test review here. So this video will be kind of long, so I would kind of look at the description. If you need to skip a section, maybe you're not having trouble with 12.1, but maybe you're having trouble with 12.2, and so forth. I'll have those timestamps in the description of the video here down below. So in 12.1, we kind of looked at a couple different things, okay? One of the things is when we had a tangent line. So 12.1 was all about tangent lines. Remember, we had basically three different things that we were looking at. So they formed 90-degree angles when they intersected with either a radius or diameter, okay? And so basically that means for number 2, number 1, we can sketch in some right angles. Same thing for 4, 5, and 6. They would need to be right angles if we have a tangent. And then 7, you also have the right angle there. Okay. So, for number 1 here, now we've got a 90, 90, and a 115. Now we know that the angles inside a four-sided figure add up to equal 360. So that means that 360 minus the 90 minus the other 90 that we added minus 115 leaves us with 65 degrees for the angle. For the others, we're not trying to find missing angles. Oh, sorry. So for number 7, we'll be finding a missing angle. So we have a triangle. So we know we have 180 degrees. We subtract out the 90 we know about, and we subtract out the 40 that we already have. So we are left with 50 degrees for angle X. Okay. Then the next thing that we learned about tangent lines, okay, that basically you can form, since we have 90-degree angles, you can use Pythagorean theorem to solve for a missing side or for a missing radius. Okay, so in this case for number 2, we have 6 squared plus 8 squared, and I'm going to set it equal to c squared because we don't know the whole hypotenuse yet. So I've got 6 squared is 36, plus 8 squared is 64. 36 and 64 is going to be 100. So that's going to equal c squared. So that means the hypotenuse is going to be the square root of 100, which is just 10. So that would be the whole hypotenuse is going to be 10. Now, I'm just trying to find x, which is the outside piece. So remember, you can always copy your radius to different locations. So I had 6 here, so I've got 6 here. Okay. So to find x, it's that little piece that's left. So you have to subtract the 6 from the 10, and you're left with 4. Okay. For 4 through 6, it's asking if we have a tangent line. So that means it's basically asking, does a squared plus b squared equal c squared? Now I know for number 4, it was kind of hard to see this number. if you thought this was 13, then you're going to get that the answer is not a tangent line. But if you asked me and I told you that it was 15, then it is going to be a tangent line. You'll see why here. So when I go to set up, I've got Pythagorean theorem. So a squared plus b squared equals c squared. Remember, c is your hypotenuse. So when I go to plug in, I've got 15 squared plus 20 squared is going to equal. Now, 10 is just the outside piece. It's not the whole hypotenuse. But I know 15 is that same inside piece. So that means the whole hypotenuse is 25. So when I plug in, my c squared is 25 squared. So 15 squared is 225. 20 squared is 400. And 25 squared is 625. So when I add those two together, I do get 625 equals 625. So yes, it's tangent. If I look at number 5, so I've got a squared plus b squared. Your whole hypotenuse is c squared. So I've got 9 squared plus 14 squared. And I've got to compare that to, well, 9 and 17 is 26. So 9 squared is 81. 14 squared is 196. 26 squared, should know this off the top of my head, is 676. So 81 and 196 is 277, but that doesn't equal 676, so it is not a tangent. For 6, same thing, a squared plus b squared. See if it actually equals c squared. So I've got 10 squared plus 20 squared. I gotta see, does it equal 10 root 5 squared? So I have 10 squared is 100. 20 squared is 400. Be careful when you square this whole thing. You're squaring both the 10 and the root 5. So you end up getting 500 if you type that in your calculator. So 500 does equal 500. So yes, it's a tangent. So for 12.1, that was the last set that used Pythagorean theorem. The third thing that we did here was that tangents that intersect outside the circle have equal segments. So basically what that means is if this little piece is 4, that means this other little piece is 4. Well, if that's 4, since the whole length is 10, that means the part here in pink is 6, which means the part there for x is also 6. Okay. The last little question here for number 8. So we dealt with central angles. So what's special about central angles is that they equal the arc measure. So basically this central angle of x is equal to that arc measure of x. You also know from inscribed angles, which in this case is 25 degrees, that it's equal to half the arc. So, if the inscribed angle is 25 degrees, and that's equal to half the arc, then to get rid of the half, I would multiply by 2. So that means the arc is 50 degrees. Well, if the arc is 50 degrees, then that means the central angle, x, is also 50 degrees. Alright, so moving on to 12.2. So, for this section, we actually did it on a couple different days, just because I started out with these segments, because we took the quiz on the segments, which is what 9 through 11 are here. And then we also dealt with the angles a couple classes ago, after y'all took the quiz, or it may have been the day before, I can't remember. So we did segments one day and then angles the other day. So some of this stuff is going to be a little bit older than some of the other stuff. So looking at number 9, basically one of the things that you had to remember here, it's Pythagorean theorem again. So you have a squared plus b squared equals c squared. Again, that's when you were dealing with sides. Okay, you always had one chord here. So in this case it's x. In this case it's, well, x is half the chord. And in the case of number 11, the chord was 12. And then you always either had a radius that was drawn in, so maybe it's already formed a triangle. Remember on your quiz, you also had one where I drew the radius off to the side, so you had to remember to bring it down and form that right triangle. You may have the diameter instead given to you, like for number 10 and for number 11. So the diameter for number 10 is 12 and the diameter for 11 is 16. Okay. Either way, you're still working with Pythagorean theorem because you've got right triangles here. Okay. So when I look at 9, I've got a squared plus b squared, and I need to c, or I've got the c squared, excuse me. So I've got 3 squared plus b squared equals 8 squared. So 3 squared is 9. B squared I have to leave alone. 8 squared is 64. So when I subtract, I get b squared equals 55. So b is going to be the square root of 55. And you actually cannot break that square root down anymore. So we would have to leave it. Now in the CB class, I will allow you to do a decimal. Or you can break down the square roots if you want. For pre-AP, I'm going to expect you to break down the square roots whenever possible. So 55, there's no perfect square that goes in. So we got to leave it as 55 there. But that was just the part in the triangle. To get to the whole chord, I have to double this. So x is going to be 2 times that square root of 55, which is just 2 root 55. There's nothing special you can do with that. So for 10, so you've got to work this in a similar fashion. So since the diameter is 12, if I were to sketch in a radius here and label it as 6, now I get my right triangle. So now I have a squared plus b squared equals c squared. So I've got x squared, because x was this time just the half piece, plus 3 squared, and that has to equal 6 squared. So x squared stays the same. 3 squared is 9. 6 squared is 36. So when I subtract, you get x squared equals 27. So x is going to be the square root of 27. So for pre-AP, remember you have to break down the square root. So I've got 4, 9, 16, 25. These are my perfect squares. The biggest one that goes evenly into 27 is 9. And when you divide 27 by 9, you're left with 3. So your x is 3 root 3. If I asked for the whole chord length, you'd have to do like for number 9. You'd have to double it. Okay. For CB folks, square root of 27, it's 5 point something. I can't remember it off the top of my head. Okay. But it's in the 5s. You can also break it down for me, either way. So for 11, I've got 12 as the whole chord, so 6 is the little piece in the triangle. 16 is the whole diameter, so the radius is 8. You'll notice the radius for these is always the hypotenuse. So I've got x squared plus 6 squared equals 8 squared. So 6 squared is 36. 8 squared is 64. So when I subtract, you're left with 28 is equal to x squared. So when you go to take the square root, again for CB folks, it's going to be in the 5 range. But for the pre-AP folks, I'll go ahead and keep breaking it down. So the biggest perfect square that goes into 28 is 4. When you divide 28 by 4, you're left with 7. So your final answer is 2 root 7 for this pre-AP folks. For 12-3, what you have to do here is find the missing angles. So 12-3, we had a couple different rules that we were dealing with. So the first one was back to that inscribed angle piece. So remember, inscribed angle is half the arc. We also looked at that at 12-1. Okay. So what I mean by an inscribed angle, that means if you look at like this angle of 77 degrees, the vertex is actually on the circle. It's touching the edge of it. Okay. You'll notice for like 13, angle A. So angle A, the vertex is on the circle. Angle B, the vertex is on the circle. Angle D, the vertex is on the circle. So those are talking about inscribed angles. Okay. For 14, we're going to get to those a little bit different because you'll notice I don't have any arc measures here. Okay, so we'll deal with those here in a little bit. It's going to be a second rule. So you've also got to remember that half a circle, the arcs add up to equal 180. Full circles, the arcs add up to be 360 degrees. So if I look at 77 degrees, it's this angle. Excuse my handwriting here. So it opens up to this arc A. So that means that 77 degrees, my angle, is half of the arc A. So to get rid of that 1/2, I have to multiply by 2. So you end up getting 154 degrees. Now to find B, so I had to, the arrow was a little bit off, so it might have been hard to see. I was trying to point it at this little arc piece here. So for that angle B, we know half a circle is 180 degrees. So if I look above here, I know I need to have 180 degrees. I've already spent 154 degrees on A. So I need to subtract the 154 to see what's left for B. Because that's the arc that's left in that half circle. Didn't need the 54 degrees. Right, so when I go to look at 13 here, I'm going to use that same process to go ahead and find C. So I know the half circle is 180 degrees. So this top half needs to be 180 total between the arcs. So I've already spent 76 degrees. So that means angle C is going to be 180 minus 76. So it's 104 degrees. Alright, so now is where the complication starts to occur, especially with this one. So if you look at A is an inscribed angle. We talked about that earlier. But now, if you look at A, it opens up to that arc of 76. So the inscribed angle is going to be half the arc it opens up towards. So half of 76 gets us 38 degrees. If you look at B, well, B opens up towards that arc of 104. So that means B is going to be half of the 104, which is 52 degrees. Finally, D, because we've already found C, that was that arc. D opens up to half the circle, because it opens up at the diameter there. And we know half a circle is 180 degrees. So D is going to end up just being a 90 degree angle. We're going to go ahead and do 15 through 17 here as well while we're at it. Now for 15, there was a little error here. This 36 should have been 35 degrees. You'll see why here in a little bit. So I've got two halves of a circle. So I've got the and I know that because I've got the diameter. It's crossing through there. So if the angle here is 35 degrees, we know that's equal to half the arc, which in this case is B. So when I multiply by 2, I get that arc of B is 70 degrees. To find A is that angle. Now it's not inscribed, but it's still on the circle, the vertex is. So we're still following the same rule where it's half. And it opens up to that arc that was measured as 110. So it's going to be half of the 110. So A ends up being 55 degrees. For C is half a circle, so it's 180 degrees. And the angle that opens up towards it is D, so half of 180 means that D is actually a 90 degree angle. This kind of confirms what we did with the tangent lines. So since we have a tangent line there, we know that it has to be perpendicular to the radius or diameter. So it should be a 90 degree angle. For 16, so if we look at A, well, A is an arc in that circle. So to find that arc measure, we know the total is 360. We've already spent 90 and 150. So we have 120 degrees left. Now, if the arc is 120 degrees, that means the angle that opens up towards it, B, is going to be half of that 120. So B ends up just being 60 degrees here. For C, C is that inscribed angle, so it's half of the arc it opens up towards. So C opens up towards the 150, so it's going to be half of 150, which is just 75 degrees. For D, or for 17, excuse me, so we've got a 43 degree angle. So that's the angle, so we know it's half of the arc. So that means the arc that the 43 degree angle opens up towards is going to be 86 degrees. Okay, so that's this little piece in here. So to find D, we know half a circle is 180 degrees. We've already spent 86 degrees on that arc that we just found. So you're left with D is going to be 94 degrees. So now we got to look at those inscribed angles. So angle A opens up towards the arc of 86. So angle A is half the 86, which is 43 degrees. Angle B opens up to half the circle, which we know is 180 degrees. So that means angle B is going to be half of 180, which is just 90 degrees. And then finally, C opens up to the 94 degree arc, because it's on the other side there. And so half of 94 gives us 47 degrees. Alrighty, so I forgot to go back to number 14 there, just because we had skipped it for a little bit. So for 14, there was a fourth rule in 12.3 that we wrote down in the notes, and that was that if you had an inscribed quadrilateral, then the opposite angles were supplementary. Now, they're not equal, and you can kind of see that if you draw it, that they're not going to be equal. So in this case, we've got 80 and B are opposites, so they have to be supplementary. So 180 minus 80 leaves us with 100 degrees. For A, we've got 180 minus 75, so that leaves us with 105 degrees. All right, so moving on to 12.4, so we dealt with some angles and then segments as well. We had a couple of different rules, remember, on your strategy sheet. So the first one is if the angle is outside, so the vertex is outside the circle now, remember that you have to do big arc minus little arc, because remember it was a bad thing to be outside that inner circle of trust, divided by 2. So in this case, I don't have the big arc x and I don't have the angle y, so I can't really plug into that equation yet. So instead, remember a full circle, like what we said in 12.3, is going to be 360 degrees when you add up all the arcs. So I've already spent 95 and 72 degrees. So you have, let's see, left. I gotta do some quick math in my head here. So 265 minus 72. 193 degrees. If I mess that up, you can give me a hard time in class, I suppose. Alright, so X was 193 degrees for that arc. So now I can go ahead and plug in. So Y is my angle. The big arc we just found is 193. The little arc was 72. It's the one closest to the angle. When I subtract it, I get 121 divided by 2 gets you 60.5 degrees. For 19, remember if you had two tangents, that it was supplementary. The angle, was supplementary to the arc that it was closest to. So you've got x plus 110 equals 180. So you had x was 70 degrees. You could have also done the big arc minus the little arc divided by 2. So you subtract the 110 from 360 to get 250 here. And if you do angle is x, big arc is 250, minus 110 over 2, you get 140 divided by 2, which gets you back to the 70 degrees. Okay. So either way works. For 20, you'll notice that the angles are inside the circle now. Okay. So this is where you had to add the arcs. Didn't matter which order you added the arcs, and then divide by 2. Now, you'll notice I've got x and y. So x, that angle, is opening up towards 85. So when I look at this angle for the formula here, I'm looking at x, not at y. So I've got x is going to be 140 plus 85 degrees over 2. So x is going to be 225 over 2, still in degrees. And when I divide that out, you get 112.5 degrees. Now, x and y, they're right beside each other, and they share a line. So remember they were called a linear pair. So linear pairs have to be supplementary. So linear pairs are way back in chapter 1. So we know that x plus y have to be supplementary, so they have to be 180. We already know that x is 112.5. We're trying to find what y is. So when you subtract that from 180, you end up getting 67.5 degrees. For the bottom portion here, we had to remember a couple different rules from that strategy sheet. So hopefully you're using that and that's useful. So for like 21 and 24, at least to find x for 24, remember you've got part times part equals part times part. And remember, we've kind of got these split into pieces, and when I go to multiply my part times part, you've always got to be on the same segment, multiplying things on the same segment. So in the case of 21, we've got 8 times 7 has to equal 10 times x plus 1.6. So when you go to distribute, I've got 10x plus 16. And then you've got 8 times 7 is 56. So when you go to subtract 16 from both sides, you get 40 equals 10x. So that x value is just 4. For 24, we'll go ahead and solve for x. So you've got 3 times 13, part times part, equals 7 times x, part times part. So you've got 39, is going to equal 7x. So x is going to be 39/7. And that decimal, when you divide out, it is 5 point something. A little bit more than 5.5. Not sure what the decimal is there. For the other ones, you'll notice that their vertex is outside the circle. So for 26, sorry for the CB folks, but this is only going to be pre-AP. The other questions that are pre-AP on the review, I actually wrote it with the number. Okay. So for the other ones, you got to remember, if you're looking at the strategy sheet, it says outside times whole. We wrote it in the notes as part times whole. It's the same thing. It's going to equal outside times whole. Remember, to find the whole, you have to add the pieces. You're not multiplying. I saw some people do that on the quiz, and it'll probably happen again on the test. So be careful with that. So for the top segment here, this is a tangent. So the outside piece was labeled as x. Well, if you look, the whole segment was outside. So I've got x times x because it's not only the outside piece, it's the whole thing. The other segment, the outside piece is 6. The whole piece is going to be 18 when you add those. So you have x squared equals 108. So when I go to take the square root, got to go and look back at my perfect squares. So the biggest perfect square that goes into 108 is 36. And when I divide by 36, I get 3. So it's going to be 6 root 3. Can't remember what the decimal is. It's a little bit over 10 for the CB folks. Again, I don't have a calculator here with me because it's on the computer, so I can't really use it at the same time I'm doing this. So for 23, so I've got the outside times whole again. So the outside piece here is 6. The whole thing, I've got to add those parts. So you can either do 6 plus x or x plus 6. Doesn't matter. And that's going to equal the outside, which is 5, times the whole length, which is 21. So when you go to distribute, so 6 times 6 is 36, plus 6x is going to equal 5 times 21 is 105. So when you subtract 36, you get 6x is going to be, let's see, 69. Yeah. So when you divide by 6, you get x equals 11.5. So we'll just leave it at that. So 11.5. For 24, now we've already solved for x. Now we're just going to solve for y, and I'll solve it in a different color. Make it colorful here. So we've got, for this segment, the outside piece is 7. The whole thing would be y plus 7. And that's going to equal, in the other segment, we've got the outside piece is 6. The whole thing, I've got 3 plus 13 plus 6. So that's going to be 22. So when I go to distribute, so I've got 7y plus 49 equals, so 6 times 22 is going to be 132. So when I subtract by 49, I get 7y equals 83. So when I go to divide by 7, you end up getting, let's see what the decimal is here. Probably haven't done long division in a while. So you end up getting 11.857, and then it keeps going. So we'll just say it's about 11.9 because it said round in the nearest tenth up above. Alright, for 25, so it's outside. It has an outside vertex again. So I've got 10 is the outside piece for this one segment. 20 is the whole thing. And that's going to equal 7.5 times the whole thing is x plus 7.5. So 10 times 20 is 200. And that's going to equal 7.5x plus 7.5 squared. So when you multiply or square 7.5, you end up getting $56.25. So when you subtract 56.25 from 200, you get 143.75. It's going to be 7.5x. And when you divide by 7.5, let's see, you'll end up getting let me do my long division here. Are you thankful you'll have a calculator? So you end up getting about 19.2. Okay, so it's 19.16, and then I'll keep going. Okay. Alright, so for 26, so this one is for the pre-AP folks, or CB folks. You can go ahead and skip ahead to the next section. So we've got the outside and the whole is 6 root 6. So I'd have to multiply by itself there. Then the outside of the next piece is x, and the whole thing is x plus 15. So when I do 6 root 6 times 6 root 6, you end up getting 36, root 36, which we know is 6. That's going to equal your x squared plus 15x when you go to distribute your x. So you've got 0. We're going to go ahead and move that 36 times 6 over, equals x squared plus 15x minus 108. So now I need to figure out the things that multiply. So it was 36 times 6 is not 108. That was my issue. I was thinking, man, this one doesn't factor. I don't know what I did wrong here. So again, make sure you use your calculator on your test. Apparently my brain fails to function after 3:30. So 36 times 6 ends up getting you to 216. That's more like it. So your factors of 216, we got obviously 1 and 216. We've got 2 and 108. We've got 3 and 72. We have 4 and, let's see, 54. 5 does not work. We have 6 and 36. That's what we came from here. And then when we keep on going, 7 does not work. If you try 8, then when you do 216 divided by 8, you'll get 27. When you do 9, you'll have 9 and 24. And you could keep on going with your other numbers. I know to go ahead and stop there because I see the difference between these is 15. So I've got 0 equals, so I've got x. Now the 24 has to be positive because these have to add to get to positive 15, but multiplied to get to negative 216. So I know the 9 has to be negative. So you set each factor equal to 0, so that means x equals 9 or negative 24. Well, negative 24 doesn't make sense for a side length, so you get x equals 9. And to finish up 12.4 here on the back, so we got a pre-AP problem here. So CB folks, you can ignore me, and then I'll get to 28 here in a little bit. So for this one, it takes a little bit of extra work. You won't have one like this on your test, but you know, you might see it for extra credit or something. Something similar. But anyways, it's a good problem to go through. So we've got to basically write systems of equations. So y'all did this last year in Algebra 1 a little bit. Depending on who your teacher was and what you did after the SOLs, you might have, you know, delved into this a little bit more than some of the other classes. So the first rule of thumb here that we have is that since this arc is 120 degrees, we know that the rest of the circle, the arc there, has to be 240 because I'm subtracting from 360. So I know that x plus y has to be 240 degrees. That's one equation. Well then, if 30 degrees is the angle outside the circle, we know that the angle 30 is going to be big arc y minus little arc x divided by 2. which means that 60 is going to be y minus x. Sorry, y minus x. So I'm going to go ahead and flip that around. We're going to say that negative x plus y is going to equal 60. Same thing. Okay. So we're going to go ahead and line that up. So we've got negative x plus y is going to be 60 degrees. And you learned last year that you could actually add these equations, and you'll notice the x's cancel. So you have 2y is going to be 300. So y is going to be 150. And if I go to plug in, we know x plus the 150 has to be 240. So x is going to be 90 degrees. Okay. So hopefully that one wasn't too bad, but it was just systems of equations. Okay, so x was 90, y was 150. So for the CB folks, you can go ahead and join us back here. So this is another part times part equals part times part. And they want to know the length of the longer plank. So basically, once we find x, we got to find which chord is longer. So I've got 12 times x, part times part, equals 9 times 8. We know 9 times 8 is 72. So 12x equals 72. So when you divide by 12 and isolate that x, you get x is 6. Okay. So that means this one chord is 12 plus 6, which is 18 feet long. The other chord is 9 and 8, which is 17 feet long. So the length of the whole chord was 18 feet. X was 6, but the whole chord was 18. So moving on to 12.5. So remember in 12.5, this is what we did last class. We had x minus h squared plus y minus k squared equals r squared. And remember the center was h comma k. So for the first one here, so I've got x minus 0, because it's h and k, squared plus y minus 0 squared equals 4 squared. So when you subtract by 0, you just get x. So x squared plus y squared, 4 squared we know is 16. That one's done. For 30, works the same way, h and k. So I've got x minus 0 squared plus y minus 5 squared is going to be 3 squared. So x minus 0 again is x squared plus y minus 5 squared. Can't do anything with that. 3 squared we know is 9. For 27, so h and k, so I've got x minus 9 squared plus y. Now, minus a negative 3 is the same thing as adding 3. You'll learn something called like leave, change. So minus a negative 3 is the same thing as adding 3. And then 7 squared we know is 49. And you're done with that. Now for 32, remember it took a little bit more work when we did this in class. So we've got x plus 4 squared plus y minus 0 squared, which is just y squared, equals, now we don't know the radius, so we got to leave it as r squared. Okay, so now I can plug in x and y to find what r squared is. Okay. So we know we're going to have an equation, x plus 4 squared plus y squared equals, and then we got to figure out what the r squared is. So when I plug in 2 for x, we get 2 plus 4 squared plus 1 squared equals your r squared. 2 plus 4 we know is 6, so 6 squared plus 1 squared. So 6 squared is 36, plus 1 gets you to 37 for r squared. So that's my final answer there. X plus 4 quantity squared plus y squared equals 37. For 33 here, so you're basically working backwards. So remember you've got x minus h squared plus y minus k squared equals r squared. So we'll start with the easy one first, the radius. So square root of 1 is just 1. For number 34, you've got your radius is square root of 5, which is a decimal, so I'm going to leave it as root 5. Can't break it down any. For your center point, so it's basically the opposite sign, so x plus 1 is the same thing as subtracting by negative 1, so that's your h. And then the k value you subtracted by negative 3, that's why it turned into a plus. For 34, the center is 1 because I subtracted by 1, so that's my h. And your k you subtracted by negative 2 to get to the plus 2. 35 is for the pre-AP class again. So we've got the location of the radio station. So the radio station is the center, okay? Because it obviously radiates, hence radio, the noise or music from the center, from where it's actually located. And then it says a town located at 149, 138 is on the edge of the circle. So that's on the circle. Okay, so it's working kind of the same way as 34 there, just bigger numbers. And then basically it wants to write the equation of the circle. Okay, so I've got x minus 113 squared plus y minus 215 squared equals your r squared. Okay, so now we got to find r. It's going to be a big number. So you plug in your x and your y. So you have 149 minus 113 squared plus 138 minus 215 squared. We know that's going to be r squared. So 149 minus 113 is 36 squared plus 138 minus 215 is going to be negative 77 squared. So I'm going to do a little cheating here. So 36 squared is going to be 1296 and 77 squared is going to be 5,929. I forgot what 36 squared was. That's right, 1296. So when I add those two together, we're going to get a big number for r squared. It's going to be 7,225. So my equation in the circle, so I've got x minus 113 squared plus y minus 215 squared equals 7,225. Okay. Now, if I was multiplying the size of the reception by a factor of 4, so I'm trying to multiply the area by 4, that means the radius would basically have to double, which means the radius squared would have to multiply by 4. So the station wouldn't actually move. So the center would be at the same position. The only thing that would be affected is your r squared would have to multiply by 4. So when you do 7,225 times 4, you get 28,900. Okay. For the last little bit, we got 3 more questions and we're done here. So remember, half a circle is 180 degrees. So if I want to find the arc measure, that's in degrees. So it's 120 degrees here. This is from 10.6 and 7. For 37, now we got to find the arc length. So remember, arc length is angle divided by 360 times whatever your circumference is. So we've got the angle we know is 120 over 360 times 2 times pi. The radius was 6. So when you do 120 over 360 times 2 times 6, you should get 4 pi, and I forgot to do units, but it would be units. So remember, you don't actually multiply the pi into your calculator. Now if I'm trying to find the area of that sector, so I'd have the same angle over 360, but now I got to multiply it by area because I'm finding area. So pi r squared. So I've got 120 over 360 times pi times the 6 squared. So you'll end up getting 12 pi, whatever those units are, squared. So I hope this video was helpful for you. If not, well, you don't have to watch it again, right? So good luck on your studies for the test. Remember, I'll be here Wednesday mornings, and then Wednesday after school I stay until 4. So if you have questions then, you can always ask me. Remember, Thursday mornings, I'm not in my room because I've got robotics club in the morning. So don't depend on that for Thursday morning. Okay. So if you have questions, you can always ask then.